Hi everyone, welcome to the class. Welcome to Vedantu JEE English. I'm Diksha Kaushal, your chemistry master teacher. So everybody do let me know in the chat box if I'm clearly visible and audible to all of you or not, so that we can start with the session here. Yes everybody, why so less students are here? Let us see. Join in everybody, join in fast. Today we'll do chemical equilibrium and it's a very important lecture, and is in this lecture we are going to do degree of dissociation, the numericals of. This is actually a lecture where students usually get stuck, right? And you will see a lot of previous year questions from this particular topic, that is degree of dissociation, when a general question is given related a reaction where this much compound is decomposed, this much is formed. Basically here we are going to find out Kc, Kp with different kind of methods, right? Okay, yes everybody, notes will be given to you. If you see in the description box over here, right, if you see in the description box over here, you will see ask with any doubts, right? So that is where you will get all your PDFs of the related session, and after the class as well you can ask your doubts to this one, right? Okay, yes. Now let's see that, let's start with the session. Let's see how to calculate equilibrium concentrations. So the concentration of various reactants and product can be calculated using equilibrium constant and initial concentration. So let's see that. Yes, with the Nidhi, Mamta, Baskar, Surya, Kanaga. Yes, very good. I'm excited. Very good, very good, very good. Ma'am, how many hours this video? Maybe you can say around 1.5 hours or 2 hours, something related to that. Like by 10 p.m. will be free, right? Okay. Yes, everybody. So let's see this. The concentration of various reactants and products can be calculated using equilibrium concentrations. Guys, here theory will be nothing. So there is no theory here. No theory I have here. What I can teach you with the help of the questions here, right? So I'll teach you everything today with the help of questions, because in the question part you'll be able to understand how to apply the law of mass section with different numericals, right? So here, first question, that is JEE Mains 2020 question, that is, for a reaction x plus y give rise to 2z, 1 mole of x, 1.5 of y, when this were taken in 1 liter vessel, okay, allowed to react, the equilibrium, the concentration of z was this, the equilibrium constant of the reaction is this. Now guys, see one thing, right? Firstly, you need to understand what is the reaction, that is x plus y give rise to 2z. Okay, what is the initial concentration here? Initial concentration here is 1, this is 1.5, right, and this is 0.5. Now we will say x as the amount that is being taken out from here, that is small x, and always will represent it like that. So small x will be subtracted from the stoichiometry here, that is 1 minus x. Here it will be 1.5 minus x. And here how much amount is formed? Stoichiometry multiplied by that x. That means 0.5 plus 2x amount is formed. Okay. So what we are saying, the amount that is reacted, x is the amount reacted, okay. This is not degree of dissociation, this is not alpha. Now this is a very important thing regarding alpha and amount reacted. Now I am not talking about alpha, I am talking about the amount that is reacted. Whenever you see, you need to answer how much amount is reacted. This will be x multiplied by the stoichiometry. This is x multiplied by the stoichiometry. This is x multiplied by the stoichiometry. So here it is reacted, here it is formed, right? Once you have this, now next is they have given at equilibrium, because these are the things that you have at equilibrium, right? Now they are saying at equilibrium the concentration of Z was 1.0 mole per liter, right? So guys, if you see, these are the number of moles. Now one thing to remember, that what is there in Kc? Am I stuck? Wait a minute. Hello, hello, hello. Yes. As I saw, I got stuck. Yes, everybody. Wait a minute. Oh. Yes. Okay. Now, if you see this here, at equilibrium, this is the thing, right? Now, they're saying at equilibrium, the concentration of Z was 1, right? Now, these are the number of moles. We know that what is concentration? Concentration is number of moles divided by volume in liter, right? So, when you divide it with the volume, that will become your concentration, and volume is 1 only, so this will become the concentration. Now they are saying at equilibrium, this value is given to be 1. So you can just write it here, 0.5 plus 2x is equals to 1. So 2x is equals to 0.5, that is nothing but half. And this will be also half. So it will be 1 by 4 is the value of x here. Once you have calculated the value of x, put it here. Then this will become 1 minus 1 by 4. That is 3 by 4. This will become 3 by 4 minus 1 by 4, right? This is 3 by 4, right? So if you say 1 plus 1 by 2, 3 by 2, yes. This will be 3 by 2 minus 1 by 4, right? That will become, this is 4, and this will be 6 minus 1, that is 5. And this is already given to be 1. Okay? Yes, everybody, do you get it what we are doing? Right? So once you have this, calculate the value of K equilibrium, put it 1, this and that. Now, you know, because we don't have page here, what I'll do, I'll just, wait a minute. Okay. Now, if you see, this one is the concentration of X at equilibrium is 3 by 4. This is 5 by 4, and this is 1. Right? So you will just write K equilibrium is equals to, this is Z square by X multiplied by Y. Z square concentration by X multiplied by Y. Z is nothing but 1 square. This is going to be 3 by 4. And this is 5 by 4. You answer this. This is going to be 1 by, this is going to be 4 square. 5, 3, 15. 16 by 15 is going to be the answer here. Right? Okay, everybody. Now, let's see the next question that is asked in JEE Mains 2019. Right? Okay, duration, guys, it is like 1.5 hours something, right? So, in a chemical reaction, you have a chemical reaction. The initial concentration of B is given to you. Now, again, we are going to solve this question on the similar pattern. This is A plus 2B give rise to 2C plus D, right? This is a question. The initial concentration of B is this much times of concentration of A. If I say concentration of A, let's say it is, I have taken it as 1, then this will be 1.5. Okay? But the equilibrium concentration of A and B are found to be equal. So initial concentration, here it is given to be 0, here it is, because nothing is given, that means product concentration is 0 in the initial stage. Now we will write at equilibrium what you will do. If X is the amount that is reacted, not degree of dissociation, it is the amount that is reacted, right? So it is going to be 1 minus X, this is 1 multiplied by this. This is 1.5 minus 2x. Stoichiometry is 2, so it is multiplied by x. This is going to be 2x amount is formed. Stoichiometry multiplied by x. Stoichiometry is 1 multiplied by x. This amount is formed. Right? So this is what you have at equilibrium. Firstly, tell me, is that clear to you? This particular thing is most important here, right? That the initial, now everything is given in concentration only, so we don't need to divide it by volume or anything. Moreover, volume is not given to us, right? So directly what we will do here, they have given a hint here. What is that hint? If you can see, what is that hint, everyone? The hint is, they have given always to find x, they will give you some hint. For example, here the hint was that for Z, the concentration of Z is 1 at equilibrium. So that's why we have put this equals to 1 and we find the value of x here, right? Now, similarly here in this case as well, there will be one hint given to you. As you can see, that is given in terms of that the concentration of A and B are equal at equilibrium, right? This is a hint. The concentration of A and B are equal at equilibrium, right? Okay. Yes, very good, Kavin Raja. Thank you for your teaching. So well, I can get conceptual clarity like crazy. That's awesome. That's awesome. Kavin, that's awesome. Right? Yes. Now let's see this. Right? This is, don't worry, that is going to, one shots are going to come soon, next week itself. Don't worry about that. Right? Now see this thing. If I say 1 minus x is equals to 1.5 minus 2x, then it will become, if I take x here, 2x minus x, this will be 1.5 minus 1, this will become 0.5, and this is x. So x is equals to 0.5, that is x is equals to half. Okay. Now you put the value of x here. This is 1 minus 0.5. This is 1.5 minus, what is 2 multiplied by x, that is 1 only. 2 into 0.5, this is 2 into 0.5, this is 0.5. Okay, so it is going to be 0.5 here. This is going to be 1.5 minus 1, that is nothing but 0.5, right? Obviously they are same only. And half into 0.5 is half into 2 is 1, and this is 0.5. Now they are asking you what is the value of equilibrium constant here. So it is quite simple. Equilibrium constant will be product by reactants. Product is C square, because stoichiometry is in the power. This is A, this is B square. So C is what? C you have 1, right? C is 1 and D is 0.5, and this A is also 0.5 and B is also 0.5 square. So this will be cancelled and this will become 4. Okay, because 0.5 is nothing but 1 by 4. It will come out to be 4 here. So answer is going to be D is the correct answer. Is that clear? Right? Yes, everybody, tell me. Now let's do more questions related to that, right? Okay, let's do more questions, because the more questions you do, better it will be for you for chemical equilibrium. There is no theory in this part. You just, when you see the questions, then you will understand how to apply that, right? In this part, there is no theory here. For a reaction, this 1 mole of A and this much of B are taken in a 2-liter vessel. At equilibrium, the concentration was found out to be this, the equilibrium Kc. Again, the same category of question, right? Firstly, what we will do, everybody? Firstly, we'll write the reaction. A plus 2B give rise to 2C. Initial concentration, let's see if it is given. 1 mole of A and 1.5 of this. This is 1. This is 1.5. This will be 0. Right? Then they are saying they are taken in 2-liter vessel. No issues, will divide it by 2 if these are the number of moles. At equilibrium, what will be the answer? This will be 1 minus, at equilibrium, tell me, x is the amount that is reacted, right? So 1 minus, stoichiometry is 1 multiplied by x. This is 1.5. Why I am saying this again and again? This is very important. 1.5 minus 2 into x. because stoichiometry is 2, so it will be 2x. This will be 2x amount will be formed here, right? Okay, on the reactant side it is subtracted, on the product side it is added. Okay, yes. Now if you see, ma'am, is there any hint to calculate x here? Let's see. At equilibrium, the concentration of C was found to be this. Now they are saying at equilibrium the concentration of C was found to be this. This is the concentration of C. So concentration of C is this. That means 2x is equals to 0.35. That means x is equals to 0.35 by 2. Right? That will be the value of C. Right? Now here calculation I feel is quite weird here. Point, so I'll just use calculator here. What will be there? Okay, you should not use calculator. 0.35 divided by 2. That is 0.175. So it is nothing but it is 0.175. Okay. This is 0.175. So you can say this here. This will be 1 minus 0.175. This will be 1.5 minus 0.35 because the value of 2x is 0.35. This is 0.35. So 1 minus 0.75 is going to be 0.25. 0.175, na? Yes, 0.175. So 1 minus 0.175, that is 0.825. This is 1 minus 0.35, that is 0.65. Okay? Here to calculation is the game, otherwise to it's same, right? Now these are the equilibrium concentrations. They are asking you to find out the value of Kc. So Kc is equals to C concentration. And also one more thing, these are the number of moles, right? These are the moles that you have, right? To convert it into concentration, you need to divide it by the volume, that is 2. So this whole will be divided by 2 here. I will not solve it here because eventually it is going to get cancelled only. So this is the value of moles here. This is the value of concentration. When they have given mole, you have to convert it into concentration as well, right? So the value of Kc will be C square divided by A into B square, right? C is nothing but 0.35 by 2 whole square, and this is going to be A is 0.825 by 2, and this is 0.65 by 2 whole square, right? Okay, 2, this will cancel eventually. It will be 0.35 whole square divided by 0.825. This is multiplied by 2, it will come in the numerator, and this will be 0.65 whole square. And solve this and you will get your answer. Okay? Yes? Yes, everybody? Tell me. Ma'am, ये तो cheating है. I can use, you cannot use. Right? So, you will calculate this and you will get your answer as, wait a minute. The concentration of C was found to be this, no? Okay. Eventually, though, we are getting same thing only, right? Here they have assumed, actually they have assumed it in, let's say, chalo, this you can ignore here, right? So basically what they have done here, they have already divided it by the, this actually, if you see this, I have taken moles here. I should have taken concentration because they have given me concentration is found to be this. That is wrong. Wait a minute. And this much, that's why I was thinking this much complicated values they have given. Wait a minute. One little mistake we have done here. This is actually in moles, right? All of this is moles. So convert it into concentration by dividing it by 2. directly divided by 2 and this will become x. And they have given at equilibrium the concentration x is equals to 0.35. Now you know the value of x is 0.35. Now you can solve this. 1 minus 0.35 divided by 2. 1.5 minus 2x is what? This is 2 into 0.35 divided by 2. This will be 0.35 itself, right? Then you can just solve this value, yes. Okay, and you will get your answer here. Right, everybody? We actually correlated the value of moles here. It should be concentrations, right? So concentration is this. Initially, we should have divided it by 2. And then you solve this value and you will get your answer here. Right? Okay? Done, everybody? Put all the values here and you will get your answer here. Right? Okay? Tell me, students, if there is any problem in that thing. If there is any problem over here, then do let me know. Right? Yes. How to handle negative? Negative means what? Negative means what? Yes. Okay. Negative means what? Negative log, negative what? Achha, see, JEE 2021 question, that is 2 NOCl and this. In an experiment, this much of NOCl is placed in 1 liter. So what we have here, you have NOCl give rise to 2NO plus Cl2. And they have given the initial value. Initial is 2 moles. So here initially you have 2 moles. This was 0 and this was 0. The concentration of NO after equilibrium was found to be this. Okay. So this is 2 minus x, that is stoichiometry. This will be 2x and this will be x amount is formed. Right? And these are the moles at equilibrium. These are moles at equilibrium. Whenever you need to convert moles to concentration, you will divide it by the volume here, and volume is going to be what? Volume is going to be 1 liter, so it will be same only, that is 2 minus x, this is 2x, that is x. Why so? Because here volume is equals to 1 liter, that is why, that is the reason here it will be moles and volume will be same only, right? So now they have given you that after the equilibrium has been established, the concentration of NO was found out to be 0.4. That means this value, 2x value is found out to be 0.4. That means x is equals to 0.2, right? Now once they give you x value here, that is 0.2, you put it here. This will be 2 minus 0.2. This is 2x is equals to 0.4 and this is nothing but 0.2. So you'll see this. This is 1.8. This is 0.4 and this is 0.2. Solve the value here. What is the value of Kc? That is NO square. This is Cl2 and this is NOCl. Okay. NO is nothing but 0.4 whole square and this is 0.2 divided by 1.8. Okay. Solve this and you will get your answer here. Right? Okay, everybody. Which negative, Chintan? Which negative? Negative marking. Which negative you are talking about? Right. Yes? Clear? So solve this and you will get your answer here. Right? Was it not balanced? OMG, what mistakes I'm doing. This was not balanced only, guys. Nobody said, ma'am, it was not balanced. Just making me do it. Nobody even questioned, ma'am. Ma'am, it was not balanced. But the equation has to be balanced also, right? In that it will change. Now moles at equilibrium will change. Mole at equilibrium will be moles at equilibrium. It should be a balanced equation. So it is initial minus stoichiometry multiplied by x. This is 2x and this is 1x. Now Everything else is same, that x is coming out to be 0.2 only, so, but this is 2 minus 0.4, this is 0.4 and this is 0.2, and this will be 1.6, this is 0.4 and this is 0.2. So solve this. This is going to be 0.4 square, this is 0.2, this is 1.6, and that's how you will solve this, right? Okay, tell me everybody if that is clear. Now after solving, put all the values here and you will get your answer here. Tell me guys if that is clear to all of you or not. Is that clear? This is 2 now, so it will be 2 here. Yes. Okay. So why I'm telling you this again and again, that how to do this, because you know, in degree of dissociation, students do a lot of mistakes. That's why firstly I am showing you the questions of only when I am not taking degree of dissociation here. In degree of dissociation, we follow different concept. Okay. So this much moles of argon and this much of PCl5 are introduced to a evacuated flask of 1 liter. The system is allowed to equilibrate. At equilibrium, the total pressure of the mixture was found to be this. Okay, right? So it is an inert gas. 4 moles of inert gas is there, right? But if you talk about PCl5, it will get dissociated to PCl3 and Cl2. 4 moles are outside, you will add, but they will not react here. So how do you write it? This will be PCl5 give rise to PCl3 plus Cl2. Initial moles are given to be 5. Nothing is given about PCl3 and Cl2. That means it is 0. Now this is about moles, and if you see volume is given or not. Wait a minute, let me see. 100 liter. They are given that volume is 100 liters, so we'll have to divide it with 100. So at equilibrium, what will happen? At equilibrium, see if it is balanced. Yes, it is balanced. So this is 5 minus stoichiometry multiplied by x. In product, it is stoichiometry multiplied by x. This will be stoichiometry multiplied by x. Okay. Now you will divide it by the volume in liter. Reason being because you want to have the concentration. Right? Now they have given that 4 moles of this and this. Okay, they are asking you volume, you will not do nothing with the volume. In fact, now things will be even more different, right? Actually, you say here moles only because they are talking about Kp. So this is 5 minus x, this is x and this is x. These are the moles, right? And if you see this here, they have given you total pressure of the mixture is found to be this. Kp you have to find out, right? And another thing they are giving you, the system is allowed to equilibrate. 5 moles of this is introduced and this much. So when you calculate the total number of moles, because what is partial pressure? Partial pressure is mole fraction multiplied by total pressure, right? Mole fraction multiplied by total pressure. Total pressure is given to you, that is this much. But if you see total pressure is given, mole fraction you have to calculate. So to calculate the value of mole fraction, what you will do? PV, yes. So firstly, let's calculate the total moles. That is NT. Total moles will also include 4, that is the moles from argon, right? So it will be 5 minus x plus x plus x, that will be subtracted, plus 4. So it will be 9 plus x, that is the total number of moles. So when you divide it with the mole fraction, this is 5 minus x divided by 9 plus x into total pressure, that is given to be 6, right? Okay. This and this moles are introduced in a evacuated flask of 100 liter capacity of this. The system is allowed at equilibrium. At equilibrium, the total pressure of the mixture was found out to be 6. Okay. You know, chalo, okay, this so I'll tell you that this is x by 9 plus x, right? This will be x by 9 plus x, okay? and total pressure is 6. So I'll just multiply this with 6. But now how do I calculate the value of x here? Okay, for this, if I apply PV is equals to nRT, total number of moles is given n plus 1, R is given, T is given, volume is given, pressure is given. Can I find that? Yes. Okay. So you have to little bit think beyond it, that what are the things that we can do. So if you see, total pressure is 6, volume is given in liters, that is 100. This is 9 plus x. This R is given to be point. This is liter atmospheric only, so we don't have to change any units here. This is 0.821. You can also write it as 1 by 8, 1 by 12. So this value is also written as 1 by 12, okay, in fraction. Temperature is given to you, that is mentioned, wait a minute, 610, right? So from there, calculate the value of x, put the value of x here. Now what is pressure? Mole fraction into total pressure. So when you put the value of x, this will become the pressure, partial pressure. Then what is the value of Kp? Kp is going to be pressure of PCl3 multiplied by pressure of Cl2 divided by pressure of PCl5, and that will be your answer. Tell me guys if that is clear what we are doing here. Yes. Okay, see what we are doing here, right? They have given you that there is one reaction of PCl5 where you have also added, in the equilibrium mixture, you have also added inert gas. Now inert gas will not react with these compounds, so there will be no reaction because of argon here, but because you have added some number of moles, so that's why it will be added in total number of moles here. So initially it is given to be 500. I just applied the same method that I am doing previously. 5 minus x, this is x, this is x. I just multiply x with the stoichiometry. Then I calculated total number of moles, but in total number of moles, I also added 4, that is from argon. This is from argon. These are the number of moles from argon. So I added all of them. Then I added 4 of argon. Total number of moles became n plus x. Now to calculate the value of x, I applied ideal gas equation. PV is equals to nRT. Calculate the value of x here, put it here, then put the value of all these pressures. Tell me, is that clear everybody? Is that clear? Okay. Yes, I am watching the comments now. Yes. Tell me, any problem you have here? What we did, same, 5 minus stoichiometry into x, x. Then we now see one thing. Whenever you have, clear one thing in your head, that whenever you have moles, you will convert it into concentration. How? By moles by volume in liter is equals to concentration. Okay? And in case of Kc, you use concentration only. But when we talk about you have moles and you want to convert it into pressure, then how you will do it? Then you will do it by moles divided by total moles multiplied by total pressure. Now this you will do, this is nothing but partial pressure, and this you will do, why you will do this? For Kp. This you will do for Kp, right? Okay? Yeah, for chemical equilibrium, it's the last chapter, last lecture, right? Okay, And that's how you solve this. You can also see, go through this, then how you calculated total moles here, right? Okay, then we calculated ideal gas equation, solve the value of x from here, put it here, then you will have your answer. You can also go through the calculation part here. I'll just keep the last slide here so that you can do the calculation in the end yourself, that here what we have done. Okay, the answer will be 2.25, right? Okay, tell me, can you recall? This is the recall, na? Okay, see one thing. You have any reaction, any random reaction I'm writing. 2A give rise to C plus 3B. Okay, C plus 3B. This is the reaction that I am writing. Now in the same case, this is 2A give rise to 5B plus 3C. Okay. Now here you have 3A give rise to 4B. This is A plus 2B give rise to C plus 3D. Okay. Now condition is all of them has to be balanced, right? Now see this. Okay, this is, I'm just giving you like a general recap here what we are doing here. Whenever they say initial moles is whatever, I'm taking initial mole as 1 in every case. Let's say here it is given 1, here it is, let's say it is given 3. I'm just assuming it. Okay, let's say here it is given 2. Let's say here it is given as 4. Okay. Now different I have taken, right? X is the amount that is reacted. So how do you answer that? This is 1. At equilibrium, I'll be writing the concentration now. Here it is 0, here it is 0. Let's say here they have given this product side as 2 and here this is 0. This is given in the question itself. If nothing is given, you will take it as unity. Let's say it is given as 0, this is given as 2 and this is given as 0. Okay, now see what I'll do. See this, what I'll do. At equilibrium, I'm mentioning this by pink pen. 1 minus stoichiometry into x. Stoichiometry into x. Stoichiometry into x. Reactant side, it will be subtracted. Product side, it will be added. 4 minus stoichiometry into x. 5. This is initial add stoichiometry into x. This is stoichiometry into x. This is 2 minus stoichiometry into x. This is added, so it is 4 into x. Stoichiometry into x. This is 1 minus x because stoichiometry is 1. 3 minus stoichiometry is 2. Here it will be x, stoichiometry is 1. This will be 2 plus because already it is there. This is 3x. Now is that clear what we are doing? Right? Okay. Now is that clear what we are doing? Now, this is the first thing that I have been doing from the past 30 minutes. I'm doing the same thing in every question. I'm doing this, right? Now, I told you if mole is given, then if you have Kc, then you will divide it with volume in liter. Then you will have concentration because in Kc you put concentration. In case of Kp, you put partial pressure that you will calculate by moles by total moles into total pressure, right? Okay, clear everybody? Hana, this much detail the who will teach you, right? More than this depth, like questions also I am doing, right? So I think this is like the best thing. Achha, now see the next thing. Okay, we have recalled everything. Those category of questions we have done. Now next is, and degree of dissociation will be confusing, so stay there for that, right? Don't just go away. Relation between K equilibrium, Q and G. Now this is as it is relation that you must remember. Delta G is equals to minus 2.303 RT log K equilibrium, and K equilibrium relation with delta H and delta S is this one. Okay, this one is not that of an important relation for JEE Mains, but this one is quite important relation for JEE Mains, right? Let's see what you have here. Now, if I say delta H is positive, let's say from this equation, if I say this is positive, if this is positive, then what will happen? If I say the graph is between log k and 1 by t. So this will be y is equals to, this is whole m, this is x, this is intercept is c, and this is y. So this is a straight line graph, that is y is equals to mx plus c. So when I say this thing is positive, delta h is positive, you can see one thing here, that slope will be, slope is minus delta h naught by 2.303 r. If I say delta h is positive, slope will be, if I say delta h is positive, slope will be negative, because if this is positive, overall it will be negative, so it will go down, it will be descending, right? Intercept, as we can see, this will be the intercept here, right? If I say delta h is negative, it's an exothermic reaction. Negative negative means positive, so this is negative, negative means positive, so it is going to be an ascending slope here, that is moving upwards, right? Everybody, tell me if that is clear. Now from this equation as well, you have delta g is equals to minus 2.303 RT log of this. We can see delta g and k equilibrium, how they are. Delta g is equals to minus 2.303 RT log of kc, right? If I say this is negative, right, then this will become positive, right? If I say this is negative, then log of k has to be positive. If log of k is positive, right, if log of k is positive, log of that thing is positive when the thing that is inside is greater than 1. That means kc here will be greater than 1. If I say it is positive, if this is positive, then this log kc will become negative. Log of that thing is negative if inside the log, the value that you have, that is less than 1. So that means kc will be less than 1 here. If we say this is 0, definitely log kc is also 0. That means k is equals to 1 here, right? Okay, right, everybody? Let's do this question that is asked in JEE Mains 2022, right? Okay, yes, Shiva, yes, Shiva, yes, Shiva. But see, I'm taking class in the morning at 6 a.m. and then 8 p.m. class. Then in the middle also batch classes are there. So you can see, right, the schedule is quite tight. So I hardly get time for all of that, right? So if you see JEE Mains 2022 question here, the standard free energy change for 50% dissociation of N2O4, right? So now, okay, now if you see the standard free energy change for 50% dissociation of N2O4 into NO2 at 27 degrees Celsius, and this is given to be this, the value of X is what? Now Gibbs free enthalpy change for 50% dissociation. Now this we will not do here because here it is a case of dissociation. So we'll do this after dissociation, not here. Okay, we'll do that, but after we learn about dissociation, because dissociation concept is given now. So we have to learn the concept as well for that. Now homogeneous equilibrium means when all the phases are same, all the reactant and product are in the same phase, that is homogeneous, right? If I say heterogeneous, heterogeneous means when all of them are in different phase, right? So here all of them are in aqueous phase, all of them are in gaseous phase, that means they are homogeneous, right? Then we also know that equilibrium constant in gaseous system, if you have all the gases here, then Kp will be defined for every single component that is there in reactant and product here, right? Like Pc raised to power C, Pd raised to power D, Pa raised to power A, and Pb raised to power B, right? Now let's see this question. I think this is too simple only. For the reaction, the moles of each component, this is found to be 2. The total pressure is this. You know, this I'll give you for homework. because I have done so many same questions here. So I'm going to give you this for your homework. Let's see how many of you actually do this. Wait a minute. So I'm giving you 2 questions for your homework, right? I'm writing it over here that this is your homework question, right? That you must do. It is same as I have done before. All the questions that we have done before, it is same like that. Okay? Right, everybody? Now, let's understand heterogeneous equilibria, right? Heterogeneous equilibria means when the phases of these reactant and products are different. Like this is solid, this is aqueous, this is solid, and this is gas. That is called as heterogeneous equilibria, right? So heterogeneous equilibria, we say that activity of the pure solid and pure liquid in this case is equals to 1, right? For example, if you have this particular thing, right, you want to write the value of Kc. For solid, it is equals to 1. That's why we write it as Kc is equals to Pb2 positive and Cl negative twice, right? Okay. If you see this one, again here Kc is equals to, here this will be 1 and this is equals to 1. So you only write Kc is equals to concentration of CO2. Kp is only equals to pressure of CO2. It is not dependent upon CaCO3 or CO, right? Now let's see one question based on this, that is here, right? Okay. So it's a simple question only. It's not a complicated question, but it's a different question. Okay. It's based on a very simple thing. A 20-liter container contains CO2 at this much pressure. Okay. So if I say this is volume, this is a pressure, and in excess of CRO, the volume of container is now decreased by moving the movable piston. The maximum volume of the container when the pressure of CO2 attains its maximum value will be what? Now, if you see, Kp value is given to you here. It's a very simple question. If you see here, this is the reaction. Here, solid is 1. This is also 1. That means Kp value is actually equals to only pressure of CO2. That means Kp value is given to be 1.6. That means pressure of CO2 is nothing but 1.6. And we don't know what is the volume of CO2 when the pressure of CO2 is 1. So let's say this P2, let's take P2 as 1.6, that is pressure of CO2 when the volume is V2, that we don't know. Okay, volume we don't know here. But we know that when volume is 20, then pressure is 0.4. Now you just have to put one thing here, that is P1 V1 is equals to P2 V2. That's it. That's it. You just have to do this. P1 V1 is equals to P2 V2. So P1 V1 is what? So V2 you will find out that will be P1 V1 by P2, right? Then what is P1? P1 is given to be 0.4. Volume is given to be 20 liters, right? And this is given to be 1.6. Now solve this value. This will be cancelled out. 4, 4. This will be 2, 10, 2, 5. So answer will be 5 liter is the correct answer. Isn't it? Tell me. Yes, okay, Shiva. Yes, tell me everybody. Is that clear? What we are doing here? So it was quite a simple question. P1, V1 is given to you. For P2, they have given you a hint and they are asking you V2. Right? Okay? Got it, everybody? And that's how you have your answer here. That is B is the correct. B or D? D is the correct answer. This is D. Okay, D is the correct answer here, right? Now we come to our most confusing topic, that is degree of dissociation. Let's see. Okay, let's understand degree of dissociation. Let's understand degree of dissociation. Degree of dissociation, that is mentioned by alpha. It is taken as number of moles dissociated at equilibrium divided by initial number of moles taken, right? That is the percentage dissociation alpha multiplied by 100. Okay, these are all the definitions, but definitions they will not ask you in JEE. You have to tell the difference. When dissociation is given, how you write the equilibrium concentration. When X, that means when you have to write it in the form of X is reacted, that we were talking before, then what you do. The difference should be clear in your head, right? So now I'll just explain you with the help of some questions here. Let's say this is the example, PCl5 give rise to PCl3 and Cl2, right? Okay. Now we know that initial moles of PCl5, they will get decreased, right? And moles of PCl5 at equilibrium, then it will become constant, right? That means this much amount has been reacted here, right? So let's see this one thing here. I'll just teach you this. Okay, I'll just do this myself only. Let's see, for this one thing, I'll calculate Kp and Kc both. Okay, I'll calculate Kp and Kc both for this one thing, right? Let me just copy this and let's do how to calculate Kp, how to calculate Kc. Let's say, understand firstly one thing before calculating this thing. If in case of degree of dissociation, three possibilities are there. First possibility is when they give you, first possibility is when initial moles are given in the question. Initial moles are given in the question, right? Second possibility is initial moles are not given. Initial moles are not given. Not given. When initial moles are not given, then you will do two things. I prefer taking it as one. Either you take, assume, you can say, assume stoichiometry to be initial moles. Now when it is not given, then you will assume it to be initial moles, or you can assume 1 mole as initial mole. As initial mole. Now what I prefer is, I prefer taking 1 mole as the initial mole, right? Otherwise, different stoichiometries will be there, then you might end up getting confused. But this also you should know that we also take this. This will help you in ionic equilibrium as well, right? Okay, so this is the overall structure. Now I'll just copy paste this same slide here that we did, but now we will do and solve it in a very different way as we have done before, right? What will be that? Let's see that. Okay, now we will solve it in a very different way. Let's see how in a different way we'll solve it. Now we are talking about not X. We are not saying how much amount is reacted. We are saying degree of dissociation. So now in degree of dissociation, there is a very important point, right? Okay, it is a very important, but a degree of dissociation is how much thing has been dissociated. For example, you had 100 moles of NaCl. So I'll just write it here. For example, you have 100 NaCl molecules. Okay, let's say out of this only 50 or let's say only 30 molecules dissociated into Na positive and Cl negative. Rest of the molecules are as it is NaCl. So here you have 30% dissociation. So that's why we take what is the number of moles dissociated. How many moles are dissociated? 30. How many moles were initial? 100. So you'll take 30% as the dissociation. Okay, that's how it is taken, right? Okay, that is the dissociation, right? Now let's see what we are going to do here. That is, we have initial moles, everything I have written. I have not changed the initial moles only. right? Now let's see in some example. I'll just say, let's see in this example initial moles are not given. Let's say this, I'll say, let's say it is given, but let's say here it is not given. When initial mole is not given, then what you will do? You will take this as 1, this as 0, this as 0. So I'll take this as 1, 0, 0. Now we need to find that what will happen at concentration at equilibrium, right? Okay. How you will define the moles, right? Yes. Now if you see this is on the reactant side. You never multiply. Now always remember, on the reactant side you never multiply it with the stoichiometries. You never do that, right? So let's see this here. This is 1 is the initial. You will multiply alpha on the reactant side with only the initial moles. What I'm saying, on the reactant side you will multiply not with stoichiometry but only with the initial moles. So it is 1 minus alpha. Alpha is the degree of dissociation. This is C. Now here you will not write simply X. This stoichiometry you will take here. So this will become alpha by 2. This stoichiometry you will take here. This will become 3 by 2 alpha. Okay. That's why I'm saying that initial moles you take it as 1. Here also you take it as 1. Right? When you take the initial moles as 1, then it will become like simplified version to do what we are doing here. Right? Okay? Now see this one thing. Here it is 2A. Now this is 4 minus. It is not multiplied by 2. It is on the reactant side. It is multiplied by only the initial concentration, that is 4 alpha. On the product side, it is multiplied by this 5 as well. Then it is also divided by the stoichiometry number of moles here, that is 2. This is 3 alpha by 2. Tell me guys if that is clear. Tell me if this thing is clear. Right? Right? Tell me. Is that clear what we are doing? That's why I told you the difference here, right? That's why I told you the difference. The difference is that in terms of X, when you are saying X is reacted, beta, those to whom it is clear, if you don't tell me that it is clear, I'll not be like, I will not have that green signal to go ahead, right? See. Initial on the reactant side, this is reactant. On the reactant side, right, whatever is the initial mole, initial minus initial mole into alpha. This is what I am saying. On the reactant side, is it clear what we are doing on the reactant side? It is initial minus initial into alpha, that is on the reactant side. On the product side, it is 5 by 2 alpha, 3 by 2 alpha. This was 1 by 2 alpha, 3 by 2 alpha. Okay? Directly understood? Yes, everybody. Now, if you see this one here, this will be initial is 2, initial minus alpha. Don't multiply it with the stoichiometry. I am nowhere doing that. But here it will be 4 by 3 alpha. Right? If you see this one here, this will be 1 minus initial is alpha. Here initial is also alpha. This will become 1 by 3 because total moles here is 3. So it is alpha by 3. This will become 3 by 3, that is alpha. Okay, tell me. It will be given in the question. It will be given in the question. Degree of dissociation will be written. That degree of dissociation is 0.3 or 30% or 50%. If you see degree of dissociation, you are going to use this method. If you don't see degree of dissociation, then the previous method that I took X. In that way, when we take X, we have a different way of writing. When we have alpha, we have a different way of writing it, right? Okay. So by this, you won't do any mistake in your exam. Otherwise, you will end up doing mistakes. Sometimes students solve by the same method. They end up getting the wrong answer in the exams. Right, everybody? Now, I'll show you some questions that how it is applied, right? So, firstly, though, we'll simply do this thing that let's calculate the value of Kc here, right? Now, this is, let's take initial as 1, this is 0, this is 0. At equilibrium, it is 1 minus initial is 1, it is alpha. Here it is 1 by 1 alpha, 1 divided by 1 alpha, right? Now, if you see, these are the moles. Let's say these are the moles. At equilibrium, I want to calculate the equilibrium pressure. So what I will do, I'll convert it into, how do you convert moles to pressure? You calculate the total number of moles. Oh, I am calculating Kp here. So I'll do Kp only because I have started with pressure, so I'll calculate Kp. Total number of moles is 1 minus alpha plus alpha plus alpha, that will become 1 plus alpha. So this will become 1 minus alpha divided by 1 plus alpha multiplied by total pressure. 1 minus, this will be alpha divided by 1 plus alpha multiplied by total pressure. Alpha by 1 plus alpha multiplied by total pressure. Now everything is clear. You have converted moles to Kp, right? So this is going to be Kp, that is equals to pressure of PCl3 multiplied by pressure of Cl2 divided by reactant, that is pressure of PCl5. Now put all the pressures here, solve it, and you will get your answer, right? Then this will become alpha by 1 plus alpha. This is Pt. This is alpha by 1 plus alpha. This is again Pt. And this is divided by 1 minus alpha, 1 plus alpha, and this is Pt. So Pt will cancel here, alpha, this will cancel here. This will become alpha square by 1 plus alpha in the division, and this will be 1 minus alpha as well, and this is Pt. So 1 a plus b minus b is a square minus b square, so this will become alpha square into Pt by 1 minus alpha square, and that is going to be your answer for this one, right? Okay, right, everybody? Yes, yes. Abhijit, don't feel that, yeah. If you're studying this for the first time, you will definitely going to find it difficult. To those students who are studying this for the fifth and maybe second or third time, they will find it easy, right? You have to revise things again and again. This is a tough topic, I know, right? But you have to do it yourself as well. So there is no need to feel depressed, right? It's okay. This is a difficult topic. You will find it difficult. You will find difficulty. Don't get depressed. Oh my God, you're not like, ma'am, in one go only I want to understand everything. Great scientists also, in one go they were not able to find the correct experiment, right? The correct true values of the experiment. You have to do things again and again and again and again. If you're falling into this journey of JEE Mains and you're getting depressed because of one topic, then what you're doing, right? Then every single day you will feel depressed, right? So you need to take these thoughts out of your mind. Okay, now this I'm understanding a little bit, ma'am. Again watch the recording, see if there will be more clarity in the second go, right? Even I myself, when I understood this topic for the first time when I was in 12th class, even I found it difficult, right? Even I was not able to understand that. Now I'm teaching you that topic. So it's not like ma'am also understood on the first go. Every single thing, when you do something, right, on the first time, you will find it a little bit tough, right? So there is no need to get depressed on that. Now let's see Kc. Kc is in the volume, right? See, this is 1. This is 1. Yeah, this is easy for 11th and 12th. Actually, Abhijit is in 9th class, I think. So for 9th class student, this is tough, right? So you're good that you're able to understand something here, right? So relax, no need to get that much depressed. This is 1 minus alpha, alpha into initial concentration, not stoichiometry. This is 1 by 1 into alpha, 1 by 1 into alpha. Now these are the moles at equilibrium. These are equilibrium moles. You have to convert into concentration. What you will do with the concentration, you will divide it with the volume. So it is 1 minus alpha divided by V, alpha divided by V, and this is alpha divided by V. Then Kc will be equals to concentration of PCl3, Cl2 divided by PCl5. Do this, put all the values, and you will have your answer. Usually here pressure Kp is asked because that still after cutting and all you get some good value. Here it is not asked usually, right? But you must know how to calculate. Now let us see what kind of questions you have here, how the questions are asked. First is JEE 2014 question based on this, right? Good. Now let's see this. If you have at a certain temperature only 50% HI is dissociated into this and this, the equilibrium constant Kc. See, 50% means alpha is going to be 50 by 100, that is 0.5. Okay, alpha value is given to you. Now you have to put everything else in terms of 50%. Let's do that. Okay, now you have to put everything else in terms of this degree of dissociation. Now is initial given to you? No, nothing initial is given to you in the question. So what we will do here, you will take initial as 1, this is 0, this is 0. So at equilibrium it will become 1 minus, this is initial is 1, so it is 1 into alpha. This will be 1 by 2, 1 by 2 into alpha, so that is alpha by 2. 1 by 2 into alpha, that is alpha by 2. Okay? So that is your moles. And what they are asking you here to find out equilibrium constant Kc. Volume is also not given. So I am assuming, so what I'll take, I'll take the concentration as 1. Because moles are not given, volume is not given, so I'll take this as 1 itself. Alpha is given to be 0.5, so this will become 1 minus 0.5. This will become 0.5 by 2, this is 0.5 by 2. So this is 0.5, this is 0.5 by 2, this is 0.5 by 2. Then you have the value of Kc here, right? What is the value of Kc, everybody? Tell me, what is the value of Kc? What is the value of Kc? Ma'am, Kc is nothing but that is, you calculate, you have all these values, H2, I2, Hi. Then put the value of Kc here. Kc is what? Kc is H2 concentration, I2 concentration, then Hi concentration, whole square. Then you put all the values, you will get your answer. Major part is only this thing. This is the major part. Everything else is easy. This is a major part. If you do mistake here, the question will be wrong. The answer will be wrong, right? If you are good there, then easily you can answer all the questions. See, JEE 2012 question is, this is given to you. The value of Kp for the equilibrium reaction is 2. Kp value is given to you. The percentage dissociation you have to find out. At a pressure of 0.5 atmospheric is what? Total pressure is given to be 0.5. Okay. Total pressure is given to you. See what we are going to do here. Right? So what I'll do, I'll just... Firstly, tell me what is the reaction? N2O4 give rise to 2NO2. N2O4 give rise to 2NO, 2NO2. Now if you see this here, now if you see this question, guys, then you will simply say, if the initial value is not given, You will take it as 1. So it is 1, this is let's say 0. So this is 1 minus, initial is 1, so it will be 1 minus alpha. So it will be 2 by 1 into alpha. That is 2 alpha. If you see total pressure is given to you, that is PT is given to be 0.5. What is the total number of moles here? Total number of moles here. Total number of moles are 1 minus alpha plus 2 alpha, that is 1 plus alpha. So what you will do? You will calculate the pressure at equilibrium. This is the moles at equilibrium. So this will become 1 minus alpha by 1 plus alpha multiplied by PT. This is 2 by alpha, 2 alpha, 1 plus alpha multiplied by PT. Now PT value is given, but alpha we don't know, right? And Kp is also given to us. So I'll solve the value of Kp here, that is given to be 2. So I'll solve it here. Kp is equals to pressure of NO2 whole square divided by N2, pressure of N2O5. Pressure of this is going to be 2 alpha by 1 plus alpha whole square, this is PT square, divided by 1 minus alpha, 1 plus alpha, this is PT, right? PT will cancel. This 1 alpha and this 1 alpha will cancel. Wait a minute. This will be this. Oh, chalo, I'll just write it like this. This will be 2 alpha whole square by 1 plus alpha whole square. So this alpha and this 1 plus alpha will cancel, and you will have 4 alpha square divided by 1 plus alpha. This is 1 minus alpha and this is PT. Okay. Kp value is here. Sometimes they just ask you this question, that what is this formula? Sometimes they ask you this much simple question, okay? Now what you have to do, put the value of Kp here. What is the value of Kp? Kp is given to be 2. This is 4 alpha square. This is 1 minus alpha square, right? A plus B, A minus B is A square minus B square. PT is given to be 0.5, that is 1 by 2. It will go here. This will become 4 into 4 alpha square, 1 minus alpha square. So we can say that means alpha square is equals to 1 minus alpha square. That means it will do 2 alpha square is equals to 1, alpha is equals to 1 by 2, alpha square is equals to 1 by 2. So alpha is equals to under root of 1 by 2. Okay, I think value of under root of 1 by 2 is given, that is 0.707. So alpha is coming out to be 0.707. And if you multiply this by 100, that will become 70.7%. That will become 71%. That is D is the correct answer here. Okay. Yes. Tell me. Yes, everybody. Tell me. Is that clear? Kc though we were not even finding. Right? Let's see. Next category. Tell me if degree of dissociation questions are clear. One more question that I had left for degree of dissociation, I believe it was I think so. There was one question that we left. I think this one. That was the same. See. This is JEE Mains 2022 question. Initially it was asked in, Acha, this so we have done. This so we have done. Wait. We have not done this. This is standard free energy change for 50% dissociation. This is a similar kind of question that we have done with a slight twist, right? In 2012, they asked you direct question, but now in 2022, they have asked you slightly different question here. So let's see what they are asking here. The standard free energy change, if you calculate the value of Kc, you can calculate free energy change. So let's focus on Kc or Kp. 50% dissociation means alpha is given to be 0.5. Okay. N25 into this, the atmospheric pressure, that means total pressure is given to be 1. And is this value of X. Now, do I need to calculate this again and again? Tell me. I have already done this here. Do I need to calculate this again? We have already done this here. We have already done this here. We've already calculated. So I'll just put this. It is not a formula. For this reaction, we have already calculated. So I'll not do it again, right? Or what I'll do, I'll just copy paste this slide, right? I'll move it there. Because again and again, then I'll be like, it is so then wrong, right? If you ask me to calculate the same thing again and again, right? Okay. So till here this is same, till here this is same, till here it is same. Yes, PT is not given to be this, PT is not given to be, but here what is given to you? Alpha is given to be 0.5 and PT is given to be, I think 1 or 2, what it was given to be 1, right? PT was given to be 1 atmosphere, right? Now when you solve the value of Kp here, right, let's solve the value of Kp. So that is going to be, Kp is going to be, if you see this here, Kp is going to be, Kp is equals to 4.1 means 1 by 2 whole square. Pt is 1 divided by 1 plus or 1 minus, that is the same thing. So you can say 1 minus 1 by 2 whole square. So this will be 4 into 1 by 4, that will cancel out. This will be 1 by 4, this will cancel out. This will be 1 by, this is 4, this is 3. So it will be 4 by 3. That is the value of Kp. So once you know the value of Kp, then what you will do? Just put it into the formula of delta G. What is the formula of delta G? Delta G is equals to minus 2.303 RT log base 10 Kp. Right? Okay? Right? Here, bacha, also remember one thing, Kp is equals to Kc. As delta Ng is equals to 1, so Kp is equals to Kc. So you can put the value of Kp here. Then delta G will be minus 2.303, R will be 1 by 12. Temperature is given to you here, that is, temperature is given to be 300, and yes, just put the value, this is 300 and this is log of 4 by 3. Then you calculate all of these and you will get your answer, right? Okay. Yes. Tell me everybody, is that clear? Is that clear to all of you or not? Okay? See, same question is asked, but they have just extended this question a little bit, right? Okay? Now let's understand another things which you will see very rare previous year question on these things. So that's why I will not get into the derivations part, but I'll just explain you a little bit about the derivation so you know from where it is coming. But that derivation is not important for you. Directly, if you know the formula, even that works. So for a dissociating substance at equilibrium, both the substance and the dissociating product is present. So at equilibrium, if let's say A is getting dissociated to B, so at equilibrium, this is also present, this is also present. So this is a dissociated substance, this is dissociating substance, both are present. There's a molar mass of this equilibrium mixture is equals to average of molar mass of the substance. So if they ask you what is the molar mass here, instead of doing all this derivation, directly remember this. mass observed is equals to mass actual divided by 1 plus n minus 1 into alpha. Alpha is the degree of dissociation here. Mass observed is what is there in the what you will observe from that equilibrium, because this is the dissociation, this is the n value, right? And actual is the actual mass that is there for that reactant. This mass is actually of reactant. Okay, so the molar mass of equilibrium mixture will be average of molar mass of these substances. It is known as observed molar mass. And what is the value of n? Ma'am, number of moles minus? No. It is sum of stoichiometry coefficient of product by sum of stoichiometry coefficient of reactants. For example, this question is given to you, right? And here, what is the value of n? That is sum of stoichiometry coefficient of product by reactant. So product is what? 1 plus 1 by 2, that is 1.5. This is divided by 1, that is going to be 1.5. Okay. So observed molar mass of the mixture at equilibrium is this. Then find out the value of alpha. How do you find it out? See, observed molar mass is given to you, that is 70. Actual molar mass, what is the actual molar mass of SO2? SO3. What is the actual? You calculate this, the actual molar mass of SO3 is going to be 32 plus 4 in 16 into 3, that is 80. Okay, so that will be the actual molar mass of reactant, right? Then what you do, apply this particular formula here, that is mass observed into mass equals to mass actual divided by 1 plus n minus 1 alpha. Okay, so just apply this formula here and you will get your answer. Mass observed is given to be 71, I think, right? It is given to be 70. It is given to be 70. This is given to be 80. And n, what is the value of n? N is coming out to be 1.5 as we have calculated. You know all the values, calculate the value of alpha from there and that will be your answer. Okay, tell me, is that clear? Okay, students, tell me. Done? Now let's see vapor density of equilibrium mixture, right? So there is a relation of vapor density as well. Let's see what is that relation. That is a very, very, very important relation that you have. Directly you must remember the relation, and still vapor density questions still they can ask you, but molar mass has very less chance. But I don't want to skip anything, so that's why I have added it. I'm telling you which is important, which is not asked, right? So that transparency I am giving you, right? This still there is a chance, but molar mass has very rare chance, right? So here alpha is equals to d minus d by n minus 1 into d. What is capital D and what is small d? So here in this case, capital D is observed vapor density and this is calculated vapor density. Let's see that. The vapor density of N2O4 at a certain temperature is 30. What is the percentage dissociation of N2O4 at this temperature? See, this is the observed, whatever is given, that is the observed vapor density. That means this is capital D is given. So capital D is given to be 30. What is the molar mass? What is the actual molar mass? Actual molar mass will be 14 into 2 plus 14 into 2 plus 4 into 16. That is the actual molar mass. And how do you calculate vapor density? Vapor density, actual vapor density, right? How do you calculate? By dividing it, by dividing the molar mass. So this molar mass will be divided here and that's how you will get your, for example, capital D is given to you. You will calculate the vapor density before dissociation by calculating the molar mass, then dividing it by 2. That is the uh, formula, that vapor density is equals to molar mass divided by 2. So D is equals to uh, 28 plus 48 into, not 48, it is 64 by 2, that is 12, 6, 7, 8, 92 by 2, right? This is small d. Now, what is the value of n from here? If you see, what is the value of n? If you see this particular reaction, this is N2O4 give rise to NO2. So, n is going to be 2 by 1, that is 2. So, you have the value of small d, you have the value of capital D, you have the value of n. Just put it there and you will get your answer. This is the formula. Put all the values here and you will have your answer. Okay, right? Understood? So there is no as such like complication here in these questions. It is quite direct question. Okay, so there is no doubt that you will do any mistake here, right? So you will not do any mistake in these questions if you know the formula. In degree of dissociation and X, you might end up doing mistakes. So that's why I have taken a lot of examples there. But the chances of asking that question is more. And that is also the fact. Okay. Now let's see Lee Chatelier Principle, everybody. Do let me know if you're ready for the last part of today's lecture of chemical equilibrium. Right? Let's see. Let's see that. Tell me, guys. Shall we start? Lee Chatelier, this is one of the easiest things in chemical equilibrium, right? Lee Chatelier Principle, and the questions are also easy only that are asked, right? Not very tough questions you will see based on this. That will not be there, right? Okay. Yes. Very good, Rishit. Very good. Chalo, now focus. Lee Chatelier Principle, right? So Lee Chatelier Principle is like that stubborn kid. I'll tell that kid study and it'll be like, oh, ma'am is asking me to study, I'll not study. If I said, don't study, why you are studying, it is going to benefit you, why you want to study, relax, and like, why ma'am is saying that, like, it's like when your parents say, don't go outside, you're like, I want to go outside. What is there outside? I want to see, right? So that curiosity is among kids, na, that what if you, even in toddlers, if you tell them not to do one thing, they will definitely do that thing, right? So that thing is there. So same thing Lee Chatelier Principle will do. Whatever you, whenever something is at equilibrium, you try to disturb the equilibrium, it will do opposite of that, right? So if a change is applied to the system at equilibrium, then the equilibrium will be shifted in that direction in which it can minimize the effect of change applied, and the equilibrium is established again under new conditions. So means it will always try to reverse the effect that you have, right? Okay, yes. Now Lee Chatelier Principle, we'll see all these effects, effect of change in concentration, pressure, volume, addition of gas, change in temperature, effect of catalyst, all these changes we'll see. First is effect of change of concentration. If you see, this is a reaction. Let's say I am adding Fe3 positive ions. If I am increasing the concentration of Fe3 positive ion, then it will try to decrease this concentration. To decrease the concentration of Fe3 positive, this has to be consumed, right? If you have something in your plate, you need to eat it to consume it, to make the plate empty, right? So it's like you are sitting and you went to a restaurant, right? There is buffet system. So the more you're eating, the more it is coming in your plate. The more you're eating, more it is coming in your plate. Same thing is happening. So there is a plate in which you have Fe3 positive ions, so many Fe3 positive ions you have, right? So now what you will try to consume it so that your plate also looks beautiful. Okay, so to establish that equilibrium, they will try to consume this. When something is in excess, they try to consume it. That means they will move in the forward direction, right? Similarly with SCN, if you increase its concentration, it will try to decrease it. It will move in the forward direction. What about this compound that is on the product side? On the product side, whenever you increase the concentration of any product, it will try to decrease it. To decrease this concentration, it will have to move in the backward direction. That is why that is going to be a backward reaction. Temperature dependency also will see, Sarvesh, don't worry, right? Yes. So now same thing. If you add the reactants, right, then it will move in the backward direction. Let's say this is the reactant, this is the product. You increase this, it will try to decrease this. This will move in the forward direction. When you remove reactants, it will try to increase it. It will move in the backward direction. When you increase the product, it will try to decrease it. It will move in the backward direction. If you decrease the products, it will try to increase it. It will move in the forward direction. Okay. Yes, everybody. Now remember one thing. Addition of solid does not have any. Addition of solid has no effect. If there is some reactant or product which is solid, and you are changing the concentration of solid, right, then there is no effect. Instead of writing addition, if you change the concentration of solid, it will not have any effect there. Okay. Okay. Yes. I don't know about me being cyclone, but I definitely know your exam is going to be cyclone if you study this way. Definitely it is going to kill you, right? If you don't study now, right? Nothing will happen by getting my attention, yeah. Nothing will happen. What I am going to do in your life? I can teach you, I can provide you the knowledge. Your task is to grasp it, right? Okay? I love the students who study when it's time to study, right? Little bit fun and all is fine, right? That there is no harm in that. But please, when I'm teaching, when I'm teaching, right? My vocal cords I'm using for you, right? So I'm putting in energy to teach you, to make you understand things. You know what will make me happy? Not all these shero shairi and all these things. That will not make me happy, right? You know what will actually make me happy? When I see you guys actually taking interest in studying and understanding, right? So that is something, I want you guys to do, right? So please focus, right? Okay. See. Now it is effect in the pressure, right? So if I talk about effect of change in the pressure, always remember pressure is inversely proportional to moles. Pressure is, pressure is this much. Don't do these all things. I'll give you a direct thing here. Direct way. Remember that pressure is inversely proportional to moles. And pressure is also inversely proportional to volume, right? Just see this thing here. Now, if you see this thing here, pressure is inversely proportional to moles or volume. What you will see here, that as you increase the pressure, it will move in that direction where number of moles are less. As you decrease the pressure, it will move in that direction where number of moles are more. Okay. That thing you must understand. Okay, this thing you must understand, that as you increase the pressure, right, as you increase the pressure, it will go in that direction where number of moles are less. As you decrease the pressure, it will go in that direction where number of moles are more, right? Okay, just remember this thing. Now I'll tell you how. If you see this particular reaction here, here you will see, here also you have number of moles 2, here also total number of moles are 2. That means total delta Ng is 0. So whenever delta Ng is 0, no effect of pressure is there. No effect of pressure. Because when you increase or decrease the pressure, it is according to the difference in the number of gaseous moles. So if number of gaseous moles are same in both the sides, then there is no effect of pressure. You change the pressure, it will not change the direction of the equilibrium. Okay, it will not cause any change in the equilibrium. Now let's see this one here also. Now I'll tell you a better way and a simple direct way to understand this instead of all of these things. You know? Just remember this one thing, that here number of moles are 1, here number of moles are 2, right? So as you increase the pressure, it will go in that direction where number of moles are less. Moles are less in backward direction, so it will go in backward, right? If you increase the pressure, if you decrease the pressure, it will go in that direction where moles are more. Moles are more on product side, so it will move in the forward direction. Okay, tell me. That was the simple funda that you have here. Okay, there is no need to cram anything that always this will happen, always that will happen. That you don't need to cram. Okay, tell me. Now see this thing here. If you see this thing, this is a general chart that we have, right? But a Lee-Chatelier principle only it is going on. We are seeing different types of effects that is there, right? This is I am teaching Lee-Chatelier principle only, right? So change in moles. So I'll just explain you once more what we have done. We have done that always Lee-Chatelier principle, try to oppose whatever you do, right? Wait a minute, where it is, right? So in the reactant side, what will happen? Whenever you change, whatever you change, it will do opposite thing. When you decrease the reactant, I'll do only one thing now, right? Okay. When you decrease this concentration, it will try to do opposite, it will try to increase it. How you can increase the reactant concentration? By moving in backward direction. That is why when you decrease the concentration of reactant, it will move in the backward direction. Or let's take, ma'am, let's remove, ma'am, let's add products here. Let's add product. So when you add the product is increased. It will try to nullify the effect and it will try to decrease it. So to decrease the product, it will have to go in the backward direction. Okay. But a definition and all, you don't have to learn these definitions, huh? You don't have to. Change apply to the system at equilibrium, then equilibrium will be shifted in that direction. It can minimize the effect. It wants to reverse the effect whatever you do, right? So it will move in that direction so that it can nullify your effect that you have done. It's like someone is at equilibrium, you disturb them, then they will try to be in stable position again, right? Okay. Let's see next one. This is same thing. If you have delta Ng 0, no shift is there. If delta Ng is greater than 0, that means product is definitely greater than reactant. Here product is greater than reactant, here reactant is greater than product, here reactant is greater than product. If delta Ng is negative, that means reactant are more, That's how it will be negative, because delta Ng is number of moles of product minus number of moles of reactant. If reactant is greater, then only it will be negative. Now, if you have product is more than reactants, if I say that product is more than reactant, then if I change the pressure, if I increase the pressure, it will try to go in less number of moles. When you increase the pressure, it will go in that direction where moles are less, right? Decrease it, it will go in that direction where more moles are there. Here it will go in that direction where less moles are there. Here it will go in that direction where more moles are there. So moles are always opposite. So less moles are there in which condition? Reactant side. Reactant side. Reactant side means it will go in the backward direction, right? This is reactant, this is product. If it wants to go in the reactant side, it will go backward. More moles are there on the product side, so it will go in the forward direction. Less moles are there, here less moles are there on the product side, so it will go in the forward direction. Here more moles, so more moles are there on reactant side, so it will go in the backward direction. Okay, tell me, is that clear? Is that clear what we are doing? Tell me, everybody, right? Then change in volume. Now volume is always opposite to pressure, so same thing you can do. I'll just write delta Ng. Greater means product is greater than reactant, product is greater than reactant. Here reactant is greater than product, reactant is greater than product. If you now remember that volume and moles are directly proportional. In this case, in case of Lee Chatelier, if you increase the volume, it will go in that direction where moles are also more, right? So decreases, so it will go in that direction where less moles are there. If you increase volume, it will go in more moles. It is less mole because you are decreasing. This is more mole because you are increasing. Okay. Now, less moles. If you see reactant and product, less moles in this case are there on reactant side, so it will go in the backward direction. More moles are there on the product side, so it will go in the forward direction. See, less moles on this side are there on the product side, so it will go on the product side, that is the forward direction. Here more moles are there on the reactant side, so it will go in the backward direction. Where delta Ng is 0, no changes there, right? Okay, simple, easy peasy, right? Easy peasy. Yes, students, right? Now let's see, one student is asking this question as well. Ma'am, what is the effect when you have inert gas? Right? Ma'am, what is the effect when you have inert gas? Yes, always this principle will be applied whenever you disturb it, right? So remember one thing, no change in molar concentration or partial pressure of reactant and product as volume of the mixture is constant. So when I say volume is constant, right, because of this part, the volume is constant. Even after adding the inert gas, the volume is not changing. Let me just see. This is the number of moles of the gas before. These are the other reactants that you have. Similarly, here you will have this. But when you add inert gas, what will happen? Volume is not changing here. Okay. Let's say I am adding some inert gas, that is this inert gas. This black is my inert gas that I have added. Because the volume is constant, so the volume is not changing here. So we say no change in the molar concentration also, or partial pressure of the reactant and product, as volume of the mixture is constant. So that is why equilibrium will remain undisturbed here. So at constant volume, when you add the inert gas, there is no change in the equilibrium. if it is a constant volume, right? If it is a constant volume, because in the constant volume, guys, what is happening? No molar concentration is changing. What is molar concentration? Molar concentration is number of moles by volume, right? Because volume is not changing, so molar concentration of that equilibrium mixture is also not changing, right? Or we can say if molar concentration is not changing, that means partial pressure is also not changing here, right? Partial pressure is also not changing here because this inert gas is not reacting with the equilibrium, right? But if you have, but if you have, let's say guys, if you have which thing, if the volume is not constant, right? If I say the volume is not constant and you have added some inert gas here, okay? Volume is not constant and you have added some inert gas here. Now what will happen? Let's see. This is important. Molar concentration or partial pressure decreases as the volume of the mixture increases. You can see volume is here increasing. If volume increases, partial pressure decreases because volume and pressure are inversely proportional. Partial pressure, if partial pressure is decreasing, equilibrium will shift as in the case of increase in volume. See, tell me, if volume is increasing and partial pressure decreasing, what will happen? If volume increases, it will move in that direction where more moles are there. Similarly, if partial pressure is decreasing, then again, if pressure and moles are inversely, so again it will go in more moles. So always when you add inert gas at constant pressure, then it will move in that direction where number of moles are more. Okay, it will move in that direction where number of moles are more. Right, everybody? Tell me. Right, everybody? Now, next is effect of temperature. Right? Okay? Yes, effect of temperature. If you see this over here, this is the question that this is the Clausius-Caprion equation. And if you see this, how many times we have done this in chemical equilibrium before as well? This is, I think, third or fourth time I'll be teaching you this. So do I need to do this again? T1 into T2, T2 minus T1. We have discussed this before as well. If it is exothermic, delta H is negative. If this is negative, this whole thing always will be positive because temperature is increasing. K2 by K1 is negative. That means K2 by K1 is less than 1. That means K2 is less than K1. That means for exothermic, temperature and K are inversely proportional. For endothermic, delta H is positive where temperature and K were directly proportional. How? When this is positive, this is positive, this K2 by K1, log of K2 by K1, if it is also positive, that means K2 by K1 is greater than 1, so K2 will be greater than K1. So answer will be that if temperature is increasing, K is also increasing. Okay, tell me. Right? What you want to know from there, tell me. Which is the thing that is disturbing you? Right? What is the thing? If we say at constant volume, there is no change. Just remember this, at constant volume, equilibrium is not disturbed. At constant pressure, it will move in that direction where number of moles are more. Just remember this much, that will work. Right? Okay? Yes. Now, this also we have done before as well. If you remember, right? That for endothermic, K2 is greater, it is directly. For non-thermic, there is no change. For exothermic, it is inversely proportional, right? We have done that, right? Then what is the effect of catalyst here? Let's understand that. Effect of catalyst. The state of equilibrium is not affected by catalyst because catalyst affects forward and backward reaction in the same manner. Catalyst already only just changes the activation energy. If you see this from here, earlier this is the activation energy, it has to go this much. For example, earlier you have to cross this barrier, now you have to cross only this barrier, so it will be easy, reaction will be faster. So catalyst only changes the activation energy, it has no effect on changing the equilibrium, right? If it changes forward reaction, it also changes the backward reaction as well. So catalyst lowers the activation energy, equilibrium will be attained faster. It does not change the equilibrium is not affected. You can see equilibrium is not affected by catalyst. Forward and backward reaction both are changed on the same extent by the catalyst, right? Yes. Now see this question that you have, that is, which of the following condition will favor maximum formation of product in the reaction? Tell me. Okay, chal. Now, no, only activation energy, right? Okay. Which of the following conditions will favor maximum formation of the product in the reaction? So see, it's an exothermic reaction. That means temperature is inversely proportional to K. If you want to have a forward reaction, that means you want to increase the equilibrium constant. To increase this, you will have to decrease the temperature. That means low temperature should be there. So these two are already ruled out. Then pressure. So pressure and moles are also inversely proportional. If you want that it should be in the forward direction, so it should go in that direction where number of moles are less, because in forward direction number of moles are less. If moles are less, then pressure should be high, that means it is high pressure. So answer is E is the correct answer here, right? Okay. Then next question is, for the given equilibria, the addition of more of CaCO3 causes what? I told you solid will have no effect. When you add the concentration, increase or decrease the concentration of solid, it will have no effect. So CaCO3 will decrease, increase, no. It will cause no change here. So answer will be C is the correct answer here, right? Next is JEE 2023 question based on Lee Chatelier principle. Let's see this. JEE 2023 question based on Lee Chatelier principle. Consider the following equation. You have here where it is exothermic, the number of factors which will increase the yield of SO3 at equilibrium from the following is what? So see, it is an exothermic reaction, so temperature will be inversely proportional to K. That means I can say that if you want to increase the yield of SO3, that means you want to go in the forward direction. For the forward direction, you want to increase this, that means temperature should be decreased. So this is definitely not the correct way. Then increasing the pressure. Pressure is inversely proportional to moles. If you want to go in the forward direction where number of moles are less, here it is 3, here it is 2. So moles are less means pressure has to be more. So increasing the pressure will increase the yield, right? Okay. Ma'am, is there any we can get access to? Definitely it is in the description box, right? There is a link of Ask Ved. Click on that. You will get the PDF after this session. I think by tomorrow night you will get that. Okay. Addition of SO2. Now if you add SO2, if this is added, According to Lee-Chatelier principle, equilibrium will try to decrease this concentration. To decrease this concentration, it will move in the forward direction. So this is also correct. Addition of O2 also same. When you see reactants and products, right? When you increase the concentration of reactant, it will try to decrease it. That means it will move in the forward direction. So both are correct. Addition of catalyst will not have any effect. So this is not there. This is not there. So answer will be B, C, and D is going to increase the yield here, right? Yes, D as well. Very good, right? So answer is going to be 3, that is B, C, D. Okay, 3, that is B, C, D is the correct answer here, right? Okay, now there are some applications of Lee-Chatelier principle. Let's understand that, right? There are some applications of Lee-Chatelier principle. Let's understand these applications here. Okay, everybody, let's understand. So, easy only it is. If you say you have liquid to gas, vapor pressure, the pressure exerted by vapors over the liquid at equilibrium. So now in this case, when you have equilibrium of liquid and gas, we are saying Kp is equals to pressure of H2O and not liquid, because pure liquid is 1. Vapor pressure is independent of pressure, volume and concentration change. In this case, vapor pressure is independent of pressure, volume and concentration change, because here it is only dependent upon pressure of H2O, right? Okay. So, and this vapor pressure is independent of pressure, volume and concentration change here. So, you can say that in case of vapor, this is the simple vapor pressure only it is written. Let us see the equilibrias here. First is carbon and graphite. Vapor pressure, the beta, we know what is vapor pressure. See, I'll tell you. This is a beaker. There is a liquid, right? Liquid you have here. Now, in the liquid, guys, what you have, if you see in the liquid what you have, it forms vapors. And the pressure that is exerted by the vapors of that liquid is called as vapor pressure. Now, if you have formation of diamond, in that case, what will happen? Graphite to diamond. Now, understand one thing. Here, the density is low, and we know that density is equals to mass by volume. So, density is inversely proportional to volume. If density of graphite is low, then its volume will be high. Here, its density is high, that means its volume is low. That means we are moving from high volume to low volume. So, if volume is decreasing, tell me if the volume is decreasing, then it will go in that direction where number of moles are less. But ma'am, number of moles are same here. So this rule will not be applied here. But there is another rule that is applied, that is here heat is absorbed, right? That means delta H is positive. That means temperature and K are directly proportional. So you have to increase this particular temperature to have the forward direction. So what you need to have? High temperature you need to have. Now, ma'am, how will we answer the pressure? Right? See, if volume, I say that volume is decreasing, so pressure will definitely increase. If you see here, volume is decreasing, so definitely pressure will increase here. That's why high pressure is needed. You can't define the pressure here in terms of moles, because moles are same here. So that's how we define the pressure. Okay. Similarly, we have solid to liquid. Here also with moles we cannot define, but we can define it by density. That solid has less density. Now you will say, ma'am, solid always have more density. But in ice, because of its cage-like structure of ice, it has more density, right? Okay, because of its cage-like structure, ice has less density, and water has more density. Otherwise, solid usually has high density, but in this case, it has low density. So density is low, volume is high. It is Going from volume is decreasing, so pressure will increase. So high pressure is there. And what about temperature? For an endothermic reaction where temperature and K are directly proportional, to move in the forward direction, you need high temperature here. These are the applications for these various reactions. We apply Lee-Chatelier principle, right? Then say liquid and gas. This has high density, this has low density, because always usually solid has more density, then liquid, then gas, right? Okay, density means how heavy it is, right? Ice is an exception because of its cage-like structure. Okay, so here density is high, it is going from high to low density. So volume here is increasing, that's why pressure will decrease. So we can say that in this case the pressure is going to decrease. Yes, right? So you'll just write it here, pressure decreases. I'll explain that point as well. And here it is an endothermic, that's why temperature will increase. And now what you will see, this is another way of writing this, that when you increase the pressure, equilibrium will shift in the direction in which volume is decreasing. So opposite, if pressure decreasing is making it on this side, then if you increase the pressure, then it will go in the backward direction where volume is decreasing. This is just another way of writing this, right? Okay, in which volume is decreasing. Now tell me, if here in this direction, in backward direction, volume is decreasing, right? Volume is decreasing, density is increasing, and what is this boiling point? Boiling point is where the vapor pressure meets the atmospheric pressure. Because the volume is decreasing, right, that is my less vapors will be formed, and that is the reason that boiling point will increase, because vapor pressure and boiling point are inversely proportional. Okay, then these reactions, so we have seen itself in case of Haber's process, right? This is an exothermic reaction, that is why temperature is inversely proportional to K. So when you decrease if you want to have more product for forward direction, you need to have low temperature. So you need to have low temperature, right? Low temperature here. And if you want to shift it in the forward direction, it will shift in less number of moles. If moles are less here, then pressure applied will be more. So high pressure and low temperature is required for this one. Okay, right everybody? Similarly, you have contact process. Again, this is exothermic, and that is the reason temperature is inversely proportional. For forward reaction, you need low temperature, low temperature. Next is number of moles are less here. So here you have less moles, that's why pressure will be more. So high pressure is applied, high pressure. Rest of the things are about like reactant. If you increase the reactant, it will try to decrease it and it will move in the forward direction. Okay, everybody, tell me. Yes. Then there is this Birkeland ID process. Again, just remember that this is endothermic. Endothermic, it is directly proportional. So if you want to move in the forward direction, you need to increase this. That means temperature will be more. So you need high temperature here. Okay. High temperature you need. And what about pressure? If you see delta Ng is 0 here, so it has no effect of pressure here, right? Concentration of reactant must increase. So to lower the concentration of that, it will move in the forward direction. Okay, right everybody? So the question is, KMnO4 can be prepared for K2MnO4 as per the reaction. The reaction go to completion by removing OH negative ions by adding what? Now this is an interesting question, okay? So you want to remove OH negative. As per the reaction goes to the completion. As you remove OH negative, product is decreasing. When you decrease the product, it will move in the forward direction. Okay, then it will go to the completion. So how you can eat this OH negative, that you have to tell here. You can use CO2 or SO2 or HCl or QH. See, QH definitely will not be used here, right? If you use CO2, right? Now you may also think, ma'am, we can use HCl, but HCl is a very strong acid, right? So if you use CO2, it will form like HCO3, that is a bicarbonate ion. I think so we should use CO2, okay? HCl and SO2 are reducing agent, that's why they are not used here, right? So they are reduced, so they can reduce MnO4, reaction will be different only. CO2 is neither oxidizing nor reducing agent, so it is provide only acidic medium, so it can, so when CO2 eats OH negative, it does not react with anything else, then it shifts the equilibrium towards forward direction. So answer is A is the correct answer here. Right, everybody? Tell me. Yes. You don't even need to remember this. They will be repeated so many times in chemistry. What is Haber's process, contact process, and you should know this. You don't need to remember the name here, but you must know that this is an endothermic process. N2 plus O2 NO is endothermic process. This you must know. That contact process is exothermic and Haber's process is exothermic. You don't have to remember the values here. Just remember that this is exothermic or it is endothermic, right? Then for the reversible reaction, this plus this bit we have just done, that you want to shift the equilibrium towards the forward direction. If you decrease the pressure, it will move in more moles, so it will move in backward direction. Increasing the concentration of NH3, you will decrease it and you will move in backward direction. By decreasing the concentration, definitely not. Reactant concentration should be increased, right? So by increasing the pressure, if you increase the pressure, it will move in that direction where less moles are there. Decreasing temperature, as temperature and K are inversely proportional, you decrease temperature, K will increase. So D is definitely the correct answer, right? Okay. Beta, I don't understand. When I say it 1, 2, 3 times, then why don't you ask then? When I jump to the next question, then you ask me. What is this habit? I don't understand that. I've told you that CO2 is neither oxidizing nor reducing agent. HCl and SO2 are oxidizing agents, so they will, are reducing agents, so they will react with this MnO4 negative. That's why it is not, we don't want any other reaction to take place. Okay, right? Yes, we don't want any other reaction to take place, and CO2 is the best for that, right? Chal, now let's see now let's see last thing here, that is simultaneous equilibrium, right? Simultaneous equilibrium. Let's see what is that. See, this will be useful in ionic equilibrium. So simultaneous means, for example, two processes are going on simultaneously and they have something in common. For example, this is A give rise to B plus C. Then this B is giving rise to C plus D. Okay? Right? Now these are going on simultaneously. Let's say initial concentration here they have given 1, or let's say this is given to be C. If this is C, this will be 0, this will be 0. At equilibrium, apply the same thing. Let's say alpha is the degree of dissociation. So this will be C minus C alpha, initial minus initial into C alpha. This will be 1 by 1 alpha. This C alpha will be multiplied here as it is. This C alpha will be multiplied here as it is. Whatever you have here, that will be multiplied as it is here. Right? Okay? Now if you see this here, right, that you have done. Now if you see this here, this is, now I'll take this as C alpha, this is initially 0, this is 0. So let's say this is alpha 1. Let's say here degree of dissociation is 1. Let's say here degree of dissociation is 2. In the second equilibrium, degree of dissociation is 2. So how much it is taken out? C alpha 1 minus C alpha 1, that is the initial concentration, minus alpha multiplied by alpha 2. So this will be, wait a minute, this will be C alpha 1 minus C alpha 1 into alpha 2. Okay, this is going to be, I'll just write this here, C alpha 1 minus C alpha 1 multiplied by alpha 2. Initial concentration multiplied by degree of dissociation. I am doing the same thing. Initial concentration multiplied by degree of dissociation. Now this whole term you will put here. So I'll just do one thing. This is C and this is D. Okay, so this will be C into alpha 1 alpha 2. This will be C into alpha 1 alpha 2. Now what are the common things here? What are the common things here? Common is B. Common is this B. So you'll have to make this B equal in both the cases. So what you will do, here you will add this thing, that is C alpha 1 minus C alpha 1 alpha 2. Right? Here you will add C alpha 1 from here. Because it is common, so what you have taken here, you will add here. What you have taken here, you will add here. Okay? Right, everybody? Tell me. Thank you, Sudarshan. Thank you so much. Have single K value. No, K value are different here. It's just that when in the same equilibrium mixture, two same compounds, two same ions or compounds are there, then for example in a beaker you have salt that you have added and someone else has also added that salt. So it's not like you will calculate only that salt that you have added. So this B is also given by this A and it is also used here. So this will be the full-fledged concentration of B here, right? Okay. Actually, we'll do more of simultaneous equilibrium. Actually, ionic equilibrium is like, we will do this like really so many questions. There is so many problems, formulas that are based on simultaneous equilibrium only, right? I can give you one more example here of simultaneous equilibria. Let's say you have, wait a minute. Okay, let's say you have A give rise to B plus C and A give rise to D plus C. So these are the two equilibriums that you have, right? In a simple way, I will write it. Now in a simple way, I'll write, that's why I wrote it in a complex way, nothing is given. For example, they have given this concentration to be X, right? Let's say this is given to be X, this is 0, this is 0, right? And here it is, let's say equilibrium concentrations are given here. At equilibrium, they have given this to be X, this is Y, this is Z, and this is also, this is given to be A, B, and C. Now this is, if this is a condition of simultaneous equilibria, if they are occurring in the same beaker, right? then we will say here you will, because here concentration of A is also X and here it is A. So you will add A here and here you will add X. B, E, D or this you will not add anything else. But in case of A you will add because that is common. So in simultaneous equilibria, the common reactant should have same concentration on both the sides. This is a simple way of telling you, right? So two equilibria existing in one reaction mixture having a common reagent is called as simultaneous equilibria. Change in common reagent causes change in the both equilibria at the same time. Common reagent has same concentration in both equilibria. Okay, right? Yes, everybody? Clear? Solid state is not there in JEE Mains, it is in JEE Advance. Okay? So I'll take it after that. Firstly, right now the focus is JEE Mains. Right? Okay? Acha, EE is also common? Okay, that I didn't see. Very good. I thought I have taken it different. I don't know when I took E same. So this is here C will be added and here Z will be added. Okay? So common reagents, very good Rasik, very good. Right? So the common reagents will have the same concentration. More of this we'll do in ionic equilibrium, right? That I'm going to start this week only. And that is ionic equilibrium. I won't say it is tough, but you have to attend all the lectures, right? Chemical equilibrium will still easy, but ionic equilibrium is little on the harder side. But if you understand this carefully, then you will not find it tough, right? But students always say that I find ionic equilibrium very tough, right? Basically the formulas are the game. Otherwise, if you know how to apply the formulas, you will find it simple only, right? Okay, yes, sure. Okay then guys, now I'll see you all in the next class. That's it for today and this is your homework. This is homework number 1. Let me see how many of you do this. And this is homework question 2, right? Okay, take the screenshot of this question. Then take the screenshot of this one. Done? Done, 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 done. Okay. Right? So that's it for today, everybody. Right? And one more very important thing for all of you, that students are, if you want to know that ma'am, what is, ma'am, how I can get my PDFs of the lecture that you have taken, just click on this, ask with any doubts. You can ask any doubt related to the sessions and you can also get your PDFs on this link. And as well as guys, if you see, go to this one, then go to this one, then you see over here, right? Then you see over here, wait a minute. Oh, I came to the live section, right? Then you see over here, click over here, right? And here you will see in the description box, and now that will be added on this video as well, Equilibria Rank Booster Test Series. Click on there. So this is a test series specially designed for attempt 1, right? And in this test series, what you have, comprehensive report card with improvement areas, 11 part syllabus, 25 full syllabus test, 3 hours each, and their video solutions are also provided. 93 high weightage topics and attempt anytime test is also available there, and all tests are available for re-attempts as well. So all of this is just right now at, even I am surprised to see the price here. I thought it would be some 2000 or something. Even I am surprised, right? Wow guys, that is such a like amazing deal that you're getting. That is just for 999, and that is actually a very low price for this test series because we have recently launched it today itself. That is why the price is 999 now, but eventually this is going to increase itself, right? Okay, yes everybody, tell me, right? So that's it. You can click and you can get your Equilibria test series, right? Okay then guys, now I'll see you all in the next class. Till then, bye bye, take care, and do write it down in the comment section your homework. Till then, bye bye, take care. Bye.